You know, I think one of the problems is computer science in an education space. I should also preface this by saying I worked for the university for about 5 years as well, so I have in IT, so I have an interesting perspective both having been at the School of Engineering and working on the other side of it. You know, computer science has been typically this very hardcore science / mathematical based study at a lot of the big major universities, and so you do wind up with this huge gap. I think how do you address that? I mean, it's hard. I think we need to, you know, I don't know that it's something that any one company or individual can do, but I mean, I think long term, education has to take a hard look at the reality of, you know, not everyone is going to be a scientist or a Nobel laureate, and that we need to maybe look at what is higher education. You know, a lot of times higher education is kind of designed around this pursuit of, well, you're going to get your bachelor's, and then you're going to get your master's, and then you're going to get a PhD, and you're going to do research, and that's higher education, you know, at a major university. And that's great. I mean, we need that. But also we need, to your point, we need a little bit more education on people. You know, I have no desire to ever be a PhD. I'm not that smart, you know, but I do want or wish I had been able to learn things like better about design patterns and that sort of stuff in college.
Yeah, I would agree with that. I think design patterns are actually the key for education in the universities. I mean, I went to MIT and there what they taught was Lisp was actually what I learned, right? So, oh yeah, never used a car or a clitter in my entire life, right? Okay, that wasn't the point. The point was they wanted to teach me about design patterns of recursion. Right? Then when I wanted to get that seeped into my brain, at the time that was modern, right? Whatever, right?
Sussman-Navelson, right?
Yeah, exactly. Right? And that was the point. It wasn't the language, it wasn't the syntax, it was the thought patterns, it was the design patterns. And so when you come out, you say, I can learn whatever language you want. I can do recursion in COBOL, right? It doesn't matter, that's not the point. And so I think the more we can get our universities to infuse design patterns and thought patterns of software engineering, the better off we'll be.
Well, I think you in previous questions, you've all kind of skirted around it. And it's like, it's fundamentals and it's history of computer science. To be quite honest, you know, my background was AI. And knowing what a Blackboard system was helps build those concurrent, highly parallel, you know, systems that we need to do to handle the massive kinds of technologies. Now, no, you're not going to go build your own Blackboard system anymore, right? But it's kind of this notion of history, of how they build things, and the fundamentals of, you know, you don't have to program in C anymore, but knowing what a pointer is and how to use it and what you do with it, I think is really important in order to be able to use Java or C# well.
You know, I have to maybe say something slightly different. We have had actually very good experience with people coming out of college compared to what you want to call veteran programs. It has to do, I think, with the new perspective that the college students have on actually what computer science is and how they're using it, as opposed to the older perspective on actually the old technology. And with the proper kind of nurturing, we've had great success with people coming out of school. And within months, they're much more productive than the best people that they were being compared with. And it came back to the original discussion we were having, really the fundamental understanding of what things are, very much supporting what we said so far. If you have a good fundamental understanding of what a system is, or what systems are, what are the components, what are the layers, what are the architectures that are out there, and actually the schools that we have dealt with have done a pretty decent job of introducing them, not maybe completing it. And then having somebody that actually shows them the steps. Okay, now you know the abstract ideas. Here is an implementation. Take a look. Let's spend a few hours kind of dissecting this thing, and you ask a lot of questions. So from that perspective, we've been very successful. Now, I have to say there are a lot of exciting areas. Going back to another question that was brought up here, there are a lot of exciting areas, but there are not thousands and thousands of people working in those exciting areas. I mean, the people who are working on concurrency of monumental amounts of data, I'll guess 1,000 around the world. It just is maybe 200 in the States, and you know the rest of the world. So I think the schools are also focusing on trying to put the basic programming staff for, I don't know, implementing enterprise accounting, whatever. All of those things have to be also filled. So the schools are very much focused on that. But you can find people, if you spend time, that come out of school and they do a pretty good job, I have to say. I've been very impressed.
Computer science versus computer engineer versus a degree versus no degree. The point is there's different ways to get the education, and there's different ways to develop the skill sets, and different, it's kind of about the innate natural skill you have for trying to delve into the problem, and whether you're rigorous in your approach or not so rigorous in your approach. And that's more, I think, determines what the end result of the type of code you will produce is than whether you got a degree in this from this school or a degree in that from another school. I think it's a little bit more about the person than it is the degree. Degrees can help, it can shape you. But,
yeah,
you
it's
know,
not more about the person. I mean, random anecdotal thing that I happen to have noticed in my career, be interesting to see if the panel agrees with this, is people who have a music background tend to be fairly effective as computer science people. Some of the reason is that you can see phrases, right? You see phrases and sort of
Nancy has a master's in music.
Yeah, okay, all right. All right. It's a random thing. I don't
I must be the exception.
but I've noticed that pattern, and it's not that background, it's the way of thinking.
And you have everything from SOX regulations, which says that the person who creates the invoice cannot be the same person who approves it, so that you don't get rogue people. There was a case at Amgen, this was like 25 years ago, where somebody actually would buy this filter way more than we ever used, and then sell them on the black market.
I remember that. I was there.
You were there? Okay, right?
That was you.
So it's really, really hard. So you have, you know, identity management and role management platforms out there, like IBM's typically Identity Manager, SailPoint, Avexa, things like that. But it's really hard to get the business to understand what roles do I have and how do I, and what rights do they have. And all I can say is really, really carefully. So there are two competing forces here. There's data privacy, and there's cost of ownership, and then there's a lot of. So again, my world in the enterprise architecture world is the world of reading Burton and Gartner and all that stuff. So there's a lot of buzz around what's the real total cost of ownership in the cloud? Is it really cheaper? And right now, actually, the economic model isn't there. If you go out 2 or 3 to it's somewhere between 3 and 7 years, it's not cheaper in the cloud. So I think it's being tested right now. And I'm afraid, personally, I'm afraid that the cloud solutions are going to get to the eToys example. They sold more toys than anybody else, but they lost $1 on every toy they sold, right? And then they're going to fold and fail, and then the industries that have used them are really going to be in bad shape.
Because they have all your data.
Well, actually, we are experimenting. I mean, our organization is actually experimenting with putting some, as I asked you, which data. There are some data that is sacred, that is in a safe. You know, the credit card information, nobody has. We have 3 locks and 4 keys and 16 signatures before anybody can get to it. Okay, that's that. But the address of a business, who cares about that data? It's public domain practically. The information about the hours of a business and the things of that sort that are really not that critical. And also, when you look at the volume that is coming and the kind of a peak and valley of the information flow, if you want to set up something that in-house that will support the maximum flow of information, you will be paying a lot of money. That doesn't make sense. But if the maximum flow is over 4 hours or 3 hours, then you kind of stand up systems and bring them down on the cloud. So we're doing some experimentation, and on certain areas, they are actually beneficial. We are playing around with it.
I think you've touched on a really interesting, deep issue. I think we could go an hour on it, but I think to your point about giving up the data, the regulatory agencies are probably a key gating factor right now. So in my job, I deal a lot with the payment card processing industry standards, PCI, DSS, that sort of stuff, and they're a huge gating factor. I mean, even if we wanted to, and I'm not saying we do, even if we wanted to put our consumer database, let's say, into the cloud, we simply can't because PCI won't allow it. You know, there's certain regulatory things, and then you layer on things like Sarbanes-Oxley, and if you're in the healthcare industry, there's all, you know, HIPAA and all that sort of stuff. Education has it's like FERPA or something like that. You know, there's all these regulatory agencies that are still very much about the traditional computing model. And so that's a big hurdle to overcome. In addition to, you know, will we lose $1 every time? Will these companies survive? You know, just another perspective is there's this huge regulatory component that also has to be addressed before a lot of companies can get really serious about putting parts of their core infrastructure in any type of cloud solution.
Yeah, we've been just to kind of complete. We've actually also been experimenting with the cloud, and you know, you don't necessarily have to have your main production data in the cloud. I mean, there are other uses for it. To handle capacity for whatever reason you can potentially look at it as a disaster recovery site. There are other uses of the cloud than just your primary production, and that's actually one of the things we're looking at pretty heavily to see, is there something else we could do? Because the reality is, it could be cost effective. I mean, in our analysis, it could be significant, actually, the costs around, you know, cloud versus, let's say, a second data center to have as your disaster recovery site. So, you know, there are potential uses beyond just your main, you know, production family jewels, if you will.